nice study.
Now you're in the whole time.
Okay. Well, now we are moving to the presentation, and it is for diurnal, monthly, and decadal MODIS surface radiative urban heat surface urban heat island and trends and function of rural soils moisture. And it's studies for Monterrey. First of all, we'll start from a kind of review of different trends this surface urban heat island with changing climates, and signals and publications are different, and in some publication it is written it's decreasing, and other groups of publication you can see here and fine increasing. And to analyze that, already previous studies analyze MODIS data for such trends for diurnal and monthly and for different time scale. And now this study, Bob and his colleague Anna, choose longer periods and analyze also on all three scales. So, as it is mentioned, what a kind of confusion about the conclusion about growing or reducing urban heat island, it was analyzed and proposed a kind of hypothesis what is depend on rural soils moisture, and can be various more than urban values. And also theoretical approach was focusing on such hypothesis presented in several papers. But it is still not clear the mechanisms and good conclusion. So for this theory, in particular for Imamura paper in 1992, it was suggested to use thermal inertia as a kind of criteria for moving increase and decrease. And here you can see how it is implemented. And following this hypothesis, cities surrounded by wet rural soils leads to warm faster for daytime heat island and cool faster nighttime. And cities surrounded by dry rural soil correspondingly slower warm daytime and cool slower nighttime for one heat island. And this study considered for Monterrey metropolitan area, and here you can see the map and kind of characteristics of the city. And for this area, using QDAPT methodology, derived local climate zones, and analyze the 10 urban and 7 non-urban classes considered for analysis. And also what kind of data meteorological was used, and land surface temperature used from Landsat 5 and also from MODIS for different periods, and also monthly precipitation data. And Landsat data used for daytime and for entire domain. You can see here averaged characteristics, and results showed what summer max temperature considered for urban heat island, and corresponding winter minimum of all three parameters considered here. And special case for precipitation is more regional signal and specific case. And next studies with Landsat showed what practically only suitable for identification of urban and rural areas for evaluation just for 2 June cycles. But less suitable for longer term analysis, which will use. So they mostly used MODIS data, and for MODIS data they use during dry period January and when wet period July with 1 kilometer resolution for more than 20 years period, and results expected special seasonal and temporal variation and high temporal but low spatial resolution, because only 1 kilometer resolution data are used, give them to smoother than last slide with previous satellite data. So MODIS use it for all trend calculation, and conclusions are, as I understand, based more on that study. So the key results, first of all, MODIS monthly mean for daytime and for nighttime. The main shows what daytime maximum and nighttime minimum in all seasons except winter time during dry months, and also a larger spread for all seasons for more turbulence day time periods. And here you can see the dynamic for different seasons. So second results for this study using MODIS data for dry daytime urban heat islands growing with intensity for half a degrees for and for nighttime it's slowing urban heat islands less substantially, but and also it is strong trends for dynamic in years. You can see. So the conclusions what provided some key results for Landsat data, mostly use it. The most important MODIS surface urban heat island results for daytime values were greater than nighttime values, except for dry season months. And corresponding to dry season daytime surface urban heat islands during this long period is increasing, while corresponding nighttime decrease. So this is what on the previous slide was visible. And also these results supporting this thermal inertia hypothesis presented in previous papers, what demonstrated on slides, and use it for first time to show what rural soil moisture can predict surface urban heat islands magnitude and trend on diurnal, monthly, and interannual time scales. So, and for future, Bob and Anna plan to continue this study and extend for the same metropolitan area with new data, and also starting new studies for other cities with different climate and precipitation patterns. And of course, analyzing also large network measurements of precipitation, and also considering segment literature results for further analysis, and analysts trying now to use International Space Station concurrent observation for surface temperature and soil moisture fluxes. So, and the final conclusions for the book were formulated: ask right questions and segment your data. So, thank you, and of course you can ask me, but even better probably ask questions to Bob directly or Anna Rivera.
Thank you for accepting to present. So we'll move to the last presentation since you're the one taking that. So in case you have any question, you can ask it after the last one.
Yeah. Okay, better to Bob.